Okay, this is the test for the, what am I doing here? The multi-purpose power supply. It's a beautiful Antec Neo Eco 400 watt, which surprisingly didn't cost us very much money, and it gives us all the voltages that we need other than our primary amplifier power supplies, which we built separately. For this test, all we need to do is we're going to short pins 15 and 16 on the power supply's primary motherboard connection, which is where all of the voltages we need will be coming from. We won't be using any of the extra cable, we'll just be testing this cable right here. So when we connect this shorts out the power supply on cable to ground, which kicks the power supply and everything inside of it on, such that all of the rails will be supplying the voltage they need, as well as the fan should spin up. So when we turn that on, you can see now the fan is spinning, meaning the power supply is on. Here we have the oscilloscope, which is set right now with 0 volts down here, and each of these is 2 volt increments. And the only one where this won't work is we do have a negative 5 volt rail, but we will worry about that when we get to it. We have 24 pins to go through. What I have on my lovely computer over here is the entire pin layout for standard ATX 24 pin power supplies, and what each pin on the entire board should give us. It starts 1 through 12 and then 13 through 24, and as you can see I have shorted pins 15 and 16 right there. Anyway, so for the first test we have pin 1 should be 3.3 volts. So we touch that and we get roughly 3.5 in there somewhere. That's pretty close. The oscilloscope doesn't show it as accurately as possible, but it's not bad. Alright, second pin is again 3.3 volts. The third pin is ground. The fourth pin is 5 volts. And that's pretty close to 5 volts. Not the perfect oscilloscope, but it's more visible than the multimeter, which doesn't have a backlight, so we decided to use this. Pin 6 is... nope, that was pin 4. Pin 5 is ground. Pin 6 is 5 volts again. Pin 7 is ground. Pin 8 is a power on switch, which is irrelevant, but it does actually show 5 volts. Pin 9 is 5 volts, and it's used to set the thing into standby. Pin 10 is 12 volts, as you can see there. Pin 11 is 12 volts. Pin 12 is 3.3 volts. Pin 13 is 3.3 volts. Pin 14 is actually the one where we're going to have an issue. We'll come back to pin 14. It's a minus 12 rail, and I'll have to change the oscilloscope for that. Pins 15 and 16 obviously are shorted right now, so there's no point in testing those. 17 should be a ground. 18 should be a ground. 19 is also a ground. Wow, that's a lot of grounds. 20 is not connected, so we'll skip that one. And then 21, 22, and 23 are all 5. There's 5, 5, 5, and 24 is ground. So, and then we'll go back and we'll move 0 up to, let's put 0 right here. So we should see negative 2, 4, 6, 8, 10, 12, about the second line from the very bottom of the screen. When we touch pin 14, which is this one, and there you have it. That is negative 12 as opposed to the 0. And that is the test for the multi-purpose power supply. Back to you, Don.